In building graphics, I will often want to display a value that isn't being directly provided. In this example, I'll be reading data from a Type A MicroLogic trip unit. This device only provides the 3 phase currents, but I want to see average current on the screen. Alternately, maybe I have a different device that provides phase-to-phase voltages and the average, but I need to calculate the unbalance on my own. In many situations, the correct solution is to create a Ch02 device in the database that calculates these values for you. That way, you can also trend the value, generate alarms, and perform other server-side operations on it correctly. Sometimes, though, a value is only needed on the display, which is what we'll do now. In Graphics Editor, I have my text object, and if my function only required one value, the solution would be easy. I could bind the content, set the bind name correctly, and add a conversion to the binding. The convert custom even allows me to apply JavaScript to the value. Unfortunately, this method only works for a single value. To work with multiple bindings at once, we'll need to use more advanced scripting tools. Instead, I'll delete this binding and create 3 new custom properties named IA, IB, and IC. I'll also create bindings to connect these properties back to the runtime engine. I'll name them IA, IB, and IC, not for the script, but so they will automatically bind if I turn this into a component. These are the standard item names for phase currents. As always, these need to be formatted as presentation. As you expect, I need a script in my text as well. Just like the setPoint script from earlier, I'll trigger a function called signal on signal change. My function's code will start similarly. The text object is the parent of the script, so evt.getCurrentTarget will point to that node. There are several ways to approach the next step. Like our setPoint script, I could store the 3 values into variables and calculate the mean, but I want something a bit more flexible. I'd like to turn this script into a snippet that can find the mean of any bindings attached to an object. So how do we get bound values when we don't know their names? We have to go down the tree, then back up. First, I'll use the function getChildNodes to find all of my child tags. I'll also need a totalizer to calculate the mean and another to store the number of bindings. I can't just use the number of child nodes because there may be nodes other than bindings. Now I can loop over all the bind tags, skipping index 0. That one is the CData tag enclosing the function. I'll first get the child tag, and only continue if its name is bind. If so, I'll increment the counter and extract the bound attribute from that bind tag. This line looks a little strange because the attribute of a bind tag that stores its target is literally called attribute. Now I can step back up to the text tag and grab the value of the binding. Keep in mind that the API returns all values as strings, so to add this value to the sum, I'll need to parse it as a floating point value. Finally, I can set the text content attribute to the sum divided by the number of bindings. At long last, we can jump to preview and test our code. If I plug 3 values into the bindings, the code will automatically update with the mean of the 3. Note that the output is not a number until all values are populated. If a blank value is possible, we might add some code to ignore a null value and calculate with the remaining values. If this is an error, we can leave the text as is, or display a real warning message or symbol. The last step, as before, is to make the code reusable. We've already written a generic function that doesn't rely on manually entering the bind names. So I can break this out into a snippet called binding mean. If this code is to be used many times on the same page, though, I would instead enable global scripts and create the function as part of the page's onLoad event. Finally, If this is to be reused over and over in the project, I'd push it up to the deploy.js folder so it's only loaded once. These are all options you need to consider when creating your own JavaScript library. Next, we'll continue learning how JavaScript can perform some common graphical operations. Until then, thank you.